Okay, so a lot of times, as you get to more advanced math classes, a lot of your work is going to be proving things, proving properties, or might say prove this or show that this is true for all vectors or circles or whatever it's going to be. So a lot of kids will struggle with that, and they want to just plug in numbers and show that it works when they use these specific numbers. But you guys have to make sure that you are showing that it works for all, which means you can't just plug in a specific number. So I'm going to show you an example of how that might look on page 562 in section 10.4. We're learning about cross products. There is theorem 8, which has 6 properties of cross products. So property 4 is that if we take A cross B, I'm sorry, A plus B, I already messed up there. A plus B crossed with C, that's the same as A cross C plus B cross C. So it's kind of like a distributive property here. Okay, and one thing that you might have learned with proofs early on is that you really should only manipulate one side. I'm going to be a little bit more lax with that for you, and especially this one, it makes a lot of sense to manipulate both sides. Okay, so as long as you can prove it without having to plug in numbers, that's kind of what I'm looking for. So we'll take a look at that left-hand side there first. So if we have A plus B cross C, now what does that look like? Okay, well, A plus B would be A1 plus B1. And you know what? I'm going to use, I'm going to do a vector, not a curly bracket there, because I want it to be clear that this is a vector in component form. A1 plus B1, A2 plus B2, A3 plus B3. Okay, and then cross C1, C2, C3. Okay, so we need to do that cross product, and it might make sense for you to kind of have like a little separate sheet of scratch paper. Okay, so I'm going to kind of do this down below and actually erase it once I'm done. So remember, when we do a cross product, I, J, K, and we'd have A1 plus B1, A2 plus B2, A3 plus B3, and then we would have C1, C2, C3. Okay, so remember first, we would have, there we go. So we would have A2 plus B2 times C3. Actually, you know what? I'm going to do this even to the side here because I'm going to clean it up before I put it up there. Okay, so we would have A2 plus B2 times C3 minus A3 plus B3 times C2. Okay, and that would be I. And then we would do, for J, we would have minus A1 plus B1 times C3 minus A3 plus B3 times C1, J. And then we would have plus and that would be A1 plus B1 times C2 minus A2 plus B2 times C1, and that would be K. Okay, so we're going to write that out pretty close to what I have there, actually. I just want to put that second value in front. So we would have C3 times A2 plus B2 minus C2 times A3 plus B3. And then, you know what? I'm going to do a bracket there. Kind of, you want to make it look nice. So I'm trying to do that. There'd be your I component. And then for my J component, I'm going to distribute that negative right away so that this first piece is negative and that second piece then will be positive. So I'm going to have, it's nice to put that positive one first. So C1 times A3 plus B3 minus C3 times A1 plus B1. And then that third component will be C2 A1 plus B1 minus C1 A2 plus B2. And there we go. Okay, so that's kind of my work down below. And now I can simplify it. So I'm going to actually take all of this and just kind of move it farther down just in case I need it. Okay, and then keep going. So then I would have C3A2. Oh, you know what? And it's better to put the lower alphabetical first. So A2C3 plus B2C3 minus A3C2 minus B3C2. And then A3C1 plus B3C1 minus A1C3 minus B1C3. And then finally, A1C2 plus B1C2 minus A2C1 minus B2C1. Okay, nothing else looks like I can simplify it there. So now I'm going to look at the second piece, that A cross C. Oops. Okay. A cross C plus B cross C. Okay, so that's going to be, and I'm going to kind of just show my work below. I'm just going to do A cross C, and I know that it's going to be the same thing if I just replace all the A's with B's. I don't think I'm going to need this guy anymore, so I'm just going to throw him down there. Okay. So again, if I have I, J, K crossed A1, A2, A3, C1, C2, C3, I'm going to get, we will have A2, C3 minus A3, C2 for the I, and then for J, I will have A1C3 negative, right? And then plus A3C1. Okay. And then for the K, there we go. And I will have A1C2 minus A2C1. And then I can do the same thing. I'm going to run out of room a little bit, but just replace all those A's with B's, right? So it would be B2C3 minus B3C2. It'll be negative B1C3 plus B3C1, and then it'll be B1C2 minus B2C1. Okay, and again, I don't think I can just delete that. I'll just erase it. Okay, don't need any of that junk anymore. Okay, so now I can add those together, and I will get, let's see, the first components will be A2C3 minus A3C2 plus B2C3 minus B3C2. And that's, again, just adding the x components there. Okay. And then I'll have negative A1C3 plus A3C1 minus B1C3 plus B3C1. And then my final component, which will be A1, running out of room here, A1C2 minus A2C1 plus, oops, you know what, I messed up here. I did a plus there. It should be a comma. Plus B1C2 minus B2C1. Now, if I did that right, it should be the same as what I have up there in the red. And we would just double check it and just note that they worked out to be the same. So let's take a look here. We got A2C3 minus A3C2 plus B2C3 minus B3C2. Those are the same. Then moving on, A3C1, A3C1, B3C1, B3C1, negative A1C3, negative B1C3, and then finally A1C2, B1C2, negative A2C1, negative B2C1. Okay, so I showed that I could manipulate the left-hand side to equal the right-hand side, and I then verified that property is true. Okay, without plugging in any numbers to show that it's true. I have shown that it's true for any three vectors A, B, and C, and that's what you need to do.